Everyone, Miss Barker here. We're going to continue with a couple of review days on fractions. So today our learning target is to recognize and create equivalent fractions. Real quick, I want to talk about this word right here, equivalent, as just a reminder. Equivalent means equal, okay? And specifically, when we're talking about fractions, it doesn't just mean the same numbers. And I think you'll see what I mean in a second and be like, oh, yeah, remember that from fourth grade a little bit. But it means the same value. So, not in the same way that 6 is equal to 6, of course it is. But what you're going to see, what we're going to do quick is create equivalent fractions using multiplication. Now, the numbers might not look the same, actually, they won't look the same, but the fractions have the same value. They are equivalent. Okay. Now, the way that we do this when we are creating equivalent fractions is to multiply our numerator and our denominator by the same number. And it can be any number. So we'll do that a couple times quick with these first two problems. I'm going to start right here with 2/3. Now, our goal again is to create a couple of fractions that have the same value and that are equal to 2/3. But it won't just be 2/3 equals 2/3. Of course, 2/3 equals 2/3, but we're going to find fractions that have different numbers with the same value as 2/3. They are equivalent. Okay, so let's do 7, just off the top of my head. Let's do 7. Whatever you do to one piece of your fraction, you need to do to the other. And what I mean by that, even when we get into addition and subtraction later next week, if you multiply your numerator times something, you need to do the same thing to your denominator. If you do that to your numerator, do the same to your denominator, same number. So I'm going to put an equal sign here because that is what we are doing, finding fractions that are equal to 2/3. I'm going to start with my numerators. 2 times 7 is 14, and 3 times 7 is 21. So we're going to make our list over here too. I'm going to start a new list. So I'm going to write 2/3 is equal to 14/21. Now these numbers are not the same, but these fractions have the same value. Okay, now we're going to erase this real quick and let's start with let's do a different multiple. So let's do 10 times 10 times 10 equals 20/30. It is also equivalent to 2/3, equal to 2/3. Put it over here, equals 30ths. Okay. Okay, and we could do really small numbers or really huge numbers. Let's do 100 times 100 times 100. Do the same as your numerator as you do to your denominator. 200 300ths. Okay, let's do, I think that's good. We found a couple of equivalent fractions to 2/3. I think you get the idea. Now let's do a few for 5/7. I'm going to start multiplying times 3 times 3. Again, we're finding equivalent fractions. 5 times 3 is 15, and 7 times 3 is 21. Okay, I'm going to rewrite that. I'm going to rewrite 5/7. So you can do another one. Let's do times 8 and find an equivalent fraction to 5/7. 5 times 8 is 40, and 7 times 8 is 56. That means that these two fractions are equivalent. They are equal. They have the same value. And 5/7 and 15/21 are also equivalent. They have the same value. Okay, we just did a couple problems where we found equivalent fractions using multiplication. Now we're going to move on to the part that's a little bit trickier. We're going to work on finding equivalent fractions by simplifying fractions, or also called reducing fractions, putting them into their simplest form. Okay, and I've only put 3 problems on here. These take significantly longer than the other ones, but what we're going to do is look at our first fraction, 12/20, and we are going to, instead of using multiplication to find equivalent fractions, we are going to use division to find an equivalent fraction that is the simplest form of 12/20, meaning we can't divide any further. The easiest way to do this, and if some of you have your fact fluency, you might not have to go through all of these steps, but at least do a couple of these in your independent practice the way that I'm modeling on here. The easiest way to do this is not to look at those two values, 12 and 20, and say, they're both whole numbers that are even. I could divide by 2. Yes, you could. But then you would find yourself dividing and dividing and dividing again. Instead, what we want to do is find the greatest common factor between those two numbers. Common factor. So just a reminder, let's say that we are multiplying 4 times 2, and we get the product of 8. 8, the product is the answer, and 4 and 2 are the factors of 8, the numbers you get to multiply together to get that product. So what we're going to do, I'm going to model the way that we did this in class. We actually did 2 different ways, and you can choose which one is the easiest for you. We're going to make a list of the factors of 12 and 20, okay? And then we want to pick the biggest one we can find that we can divide both of those numbers by. Okay, now one way that we did this is to make a list of the factors. So for example, you could do this, 1 times 12. It's a lot easier to start with your lowest counting number, which is always 1. Every number has a factor of 1 in itself. Okay, 2 times 6, and 3 times 4. So the factors of 12 are 1, 2, 3, 4, 6, and 12. Okay, that's it. Now we're going to do the same thing for 20, and what we're looking for are some factors that are the same, and actually the biggest factor that they both share. So factors of 20, I know we have 1 times 20, 2 times 10, 3 times anything, nope, because 20 is an even number. 4 times anything, oh yeah, 4 times 5, 6 times anything, 7 times anything, 8 times anything, 9 times anything, nope. Once I get to 10, I'm not going to write 10 times 2 again because we already have 2 times 10, which is exactly the same. Okay, now look at these 2 lists of factors. So the factors of 20 are 1, 2, 4, 5, 10, and 20. And what is the greatest factor that they both have? So I'm going to go ahead and look at the lists. Okay, they both have 1. That's not the biggest one. They both have 2. They both have, ooh, I see it, 4. So the biggest number we can divide both of these by is 4. So that's what we're going to do. We found our greatest common factor, which was 4. So we're going to divide both our numerator by 4 and our denominator by 4. And that will give us an equivalent fraction with smaller numerator and denominator, but that has an equal value. Okay, 12 divided by 4 is 3, and 20 divided by 4 is 5. And if you get to that point where you're doing that division, you don't have to work very hard because look, it's right here. 12 divided by 4 is 3, and 20 divided by 4 is 5. It's all right there. Okay, now, if you're thinking, well, maybe we can divide again and get really our simplest form. So I want you to think about 3 and 5. Think about your factors of 3 and 5. What numbers can you multiply together to get 3? 1 and 3. That's it. And your factors of 5 are 1 and 5. So when you get to this point, unless those numbers have a common factor other than 1, then that is the simplest form of your fraction. That means that 12/20ths is equivalent to 3/5, but 3/5 is the simplest form of that fraction. Okay, let's go start on the second one now. Some of you with really good fact fluency that you've built up throughout your elementary years or even this year, you might be able to see these common factors right away, but I know a lot of you might not. So let's start by making our list of factors again. Oops. It's 15 and 45. So I'm going to start with 1 again. 1 times 15. 2 times anything? Nope. 3 times 5. 4 times anything? I'm not going to write 5 times 3 because I already have that. And that's it. Okay. The factors of 45 are 1 and 45. 2 times anything? And if you ever get to this point where you're like, oh, can I divide that by 2? Is 2 a factor of 45? You guys all know how to do that division. You can all do a little check on the side, 45 divided by 2. I know that 45 divided by 3 is 15. And then I know that 5 times 9 is 45. And that's it. Okay, now go ahead. Let's look at our list. What do you notice is the common factor they share other than 1? Because if we divide 15/45 by 1, we're going to get 15/45 again. But I see right here, they share 15. So let's use that. We're going to divide by 15. Start with the numerator. 15 divided by 15 is 1. You can see that right here. And same thing, 45 divided by 15, you don't have to do a whole lot of division. It is right here, it's 3. Okay, now look at 1 and 3. Do they share any common factors other than 1? Because if you divide by 1, you're going to get 1/3 again. And no, the answer is they do not. Okay, next one, we're going to try our factor rainbow that we used in class a little bit. Some of you liked using that. It helped you see the relationship between factors, other than writing out these tables that we've done above. Okay, so 9 and 12. Oops. 9 and 12. So I'm actually going to do 9 and 12 over here. And this is the factor rainbow, which some of you liked. And this is where you write your factors right next to each other and you connect them with a line showing multiplication. Okay, so start with your lowest counting number again. 1 times 9 equals 9. So it's like these numbers that are connected in your rainbow, they're multiplied together. And 2 times anything? Nope. 3 times 3. 4 times anything? 5 times anything? Nope, that's it. So the factors of 9 are 1, 3, and 9. That's it. Okay, and we're going to do the same thing with 12. 1 times 12. 2 times 6. 3 times 4. And that is it. Okay, now you're going to do that same thing we did up here with these, except for you're going to look for those common factors. They both have 1. They don't both have 2. And I see the greatest common factor they both share is 3. So you are going to divide both your numerator and denominator by 3 to find an equivalent fraction that is simplified. So 9 divided by 3 is 3. And I can see that right here too, because 3 times 3 equals 9. And 12 divided by 3, oh look, 3 and 4. And that is our simplified fraction.